Hi, this is Alessandro from the Quantum Biology Institute and Quantum Biology DAO. So hopefully this one is the last video I need to make on the setting up the experiment in Maryland with the twin leaf, the tiny hypomagnetic chamber that I've been talking about in the last couple of videos. And I'm back in LA in the prototyping area with the new neon logo of the Institute. So I went to Maryland. I've been there a couple of days with Mike, sort of going through the experiment and taking through the whole setting up the hypomagnetic environment procedures. I taught him how to test for temperature, light, humidity, like I've shown in the last video. We actually managed to figure out how exactly we want the experiment to be performed. And so the one thing is that Mike is gonna use mostly little falcon tubes like this. He's gonna use these to grow these organisms he's gonna be doing studies on. And all of the twin leaf and these tubes will need to go actually in a shaking incubator, which is an incubator. An incubator is something where you put stuff to grow, basically in the best conditions possible. And it can control the temperature, it can control the gas that you have inside. And so it's something that is very standard when doing biology experiments. And the shaking incubator is what the name says, an incubator that shakes your sample. And you can control the speed of the shaking, and basically it goes in a sort of circular motion or elliptical motion, and just keeps your samples moving. And so that sort of complicates a little bit the things, because we need to have things that are nicely fixed in place and don't just go around on the shaking incubator and make a mess. We needed a way, first of all, to have as many of them as we could inside of the twin leaf, so that we just maximize the amount of samples that we have inside. That ended up being 3 of these relatively big falcon tubes. This is a 50 ml falcon tube. What I did was to design something that basically held these falcon tubes in place at an angle, because we don't want them laying flat. They cannot really stay like this, because that's too tall for the twin leaf. It just doesn't fit inside. We have a grid with a bunch of threaded holes, and so I just basically designed and 3D printed something to hold these guys in place, 3 of these in place at an angle inside of the twin leaf that can be screwed down and basically be fixed securely. Plus, we also need a space to have the magnetometer. So we want to keep the magnetometer inside to keep track of the magnetic field, that is the residual magnetic field inside, so we can basically use active compensation to minimize the residual magnetic field that we have. What I did was to 3D print this guy, which has a slot here for the magnetometer, so the magnetometer can just be put there. As you can see, it has a bunch of holes here that can be used to fix this guy in place inside of the internal volume of the twin leaf. And basically the tube just fits inside, and there's 3 slots, and these can go around, shake however it wants, and it's gonna just nicely fit in place. And I'm gonna ship this to Mike together with all the rest of the things that I'm gonna go through now. So this is one. We also want to have a control inside of the same shaking incubator, because we want to have the same parameters of temperature, light, humidity. gas, and so on. And so the platform of the shaking incubator has a bunch of threads, a bunch of holes. Basically, it's almost a square grid, but on one side it's 3 inches and 3/4, and the other side of the almost square is 3 inches and 5/8, which is wide. Apart from that, it's not too much of a deal, but I made this, which is basically same idea, so that you can have 3 inside of the twin leaf and 3 outside of the twin leaf that are still exposed to the Earth's magnetic field. I don't know if you can see that. And I also 3D printed the logo just for fun. These come with holes and basically a little bit of a slot to use this guy and lock it in place with some screws. And the last one that I did is this big sort of plate here, because the twin leaf also needs to be fixed in place. And the twin leaf already has some holes that can be used to screw down, but those are not matching the holes in the plate of the shaking incubator. Basically, I just designed this very simple adapter plate, and you see there are holes here and here, and the base of the twin leaf will fit hopefully nicely in here, and this will serve as basically a platform that's gonna shake the whole twin leaf. This is the stuff that I designed and printed, plus we got Mike some load resistors to use when doing active compensation, because the sensitivity in the current to magnetic field was way too high, and it was pretty difficult to control with the coil driver. Basically, you create a current that generates a magnetic field, and you want to bring the total magnetic field as close to zero as possible. But even just slightly touching the knob would create a big magnetic field difference. And so by adding a load resistor, we can basically change the amount of current that we put in for the same amount of voltage. The idea is that we can turn the knob much more to create the same amount of magnetic field inside. And so this gives us more control, more fine control when we're doing this sort of thing. Now, I'm just gonna ship all of this to Mike, and we also got a magnetometer. Maybe I'll leave the link somewhere in the lab notebook to just make sure that we're testing for the magnetic field inside of the shaking incubator and inside of the twin leaf, and we can reproduce the same magnetic field environment for the samples to experience. So the initial idea was to actually use a cell phone, because believe it or not, most cell phones have a magnetometer inside. I actually discovered this quite recently, but it is pretty cool, and you can download. I encourage you to do so. It's just not focusing. Yes. My God. The app is called Physics Toolbox, and it actually has a bunch of different sensors that you can use, and it's very well made. But turns out that my phone wasn't reading the same as Mike's phone, and then you sort of have a problem with reading data while your phone is inside of the twin leaf, and so it's a bit of a mess. It's just not that clean of a measurement. And so we decided to actually buy a magnetometer just for the purpose of testing the Earth's magnetic field outside of the chamber and in the environment where we have the control, and put that inside of the twin leaf, and then use some currents through the coils to reproduce artificially Earth's magnetic field inside of the twin leaf, and that's going to be the control experiment after we have done the ones with the hypomagnetic field. Now we're pretty much all set for the Maryland experiments. I'm gonna ship all of these to Mike, and as always, see you next time.